Hello, everybody. Good afternoon. Thanks a lot for coming and especially making this on Saturday afternoon. I know everybody has different priorities and things to do. But yeah, we have a good collaboration done with the Kubernetes team. Humble is the founder of that. So this is the first time we are doing with them. So let's see how it goes. The Kubernetes talk. We have some 4-5 speakers today lined up. So we'll start with Imran. Then we will be having Manikandan, Amog and Satya, and then Vaibhav. So in case you have any questions or any doubts, please feel free to ask after the session. They will address it. Thank you so much.
Good afternoon, everyone. So how many of you are here for the first time? Quite a lot. Oh my God, right? Now, how many of you have any experience with Kubernetes? Some experience. Nice. We have quite a bit of people who know Kubernetes already. So today's talks, most of them assume a little bit of knowledge of Kubernetes, right? So they might not be as beginner friendly, right? But still, like if you have any questions for the speakers, if you find it difficult to understand, you could definitely, all questions are welcome, right? So we started this Meetup group. This Meetup group started back in 2016, right? We have done 75 plus events so far. And we are an 8,000 strong Meetup group on meetup.com and 3,500 plus followers on Twitter. So we've been doing this consistently for a very long time, right? So this is probably one of our maybe 76th Meetup that we are at, right? And I welcome all of you to this Meetup. I thank Cloudera for giving us an opportunity and collaborating with us to make this Meetup happen. We have a couple of talks before the break, and then we'll break for some snacks. And then after that, we come back for the last few talks as well. There are some really interesting talks post-lunch as well, right? So which is the snacks. So I hope you all stay, and I hope you all have some good takeaways from this Meetup, right? So one more thing, we have a code of conduct. So while engaging in, even if it is criticism, engage in constructive criticism, engage in discussions with the speaker if you do not agree on some things, right? And apart from that, let's go ahead, have a great Meetup. So I will hand it over to Imran, who is going to talk about API server network proxy, right? Over to you, Imran.
Thanks. Can you hear me, guys? Okay, cool. So my name is Imran Pochi, and I'll be talking about connectivity, also known as API server network proxy. The title of the talk is basically, how do we establish cluster and control plane communication when the control plane and the worker nodes are in different networks? I work with the AKS team at Microsoft, and previously I used to work for Kinfolk, which got acquired by Microsoft. I'll share the slides if you need. You can reach out to me on LinkedIn and Kubernetes Slack. My handle is ipochi. Please, yes, please think. Okay, so what is API server network proxy? Next slide, please. So in the simplest of terms, it is a TCP proxy to establish communication or proxy for the control plane and the cluster communication. As I said, it's also known as connectivity. It is a subproject of the API machinery and the cloud provider special interest group of Kubernetes. It's a very critical piece of the ecosystem over here at AKS, GKE, IBM, Kubernetes, K0S, and others. So pretty much all of them who are providing managed Kubernetes offerings, they use this or in some other way. Yes. Yeah, sure. Sure.
Closer to you.
Before we dive further, let's take a look back at the historical context of this project. Back in 2018, Kinfolk's Michael Schubert, so he discovered a security risk with the API server. So basically, it was about modifying the pod IP, and you can trick the API server into as an HTTP proxy and reveal secrets and reveal other things when it should not. Part of that was mitigated by the use of SSH tunnels. But only one cloud provider implemented them, so only GCE worked. And the whole baggage that comes with using SSH tunnels, it was the same applicable for using SSH tunnels in Kubernetes. So rightly, it got deprecated in 1.9 and totally removed in 1.22. So all of this led to the KEP proposal back in 2019. And from there onwards, the idea was brought on about having a need for a proxy where we could not assume that all the cluster components and control plane components are in the same network or IP routable. So let's talk about the use cases, what it solves. As a Kubernetes user or admin, most of the times we've seen clusters where control plane and the cluster nodes are in the same network. But that's not the case all the time. This may be true for clusters where you fully control the control plane as well as the nodes. But there are different cases, such as Kubernetes on the edge, where the worker nodes would be on the remote endpoints and completely separated from the control plane. This is especially true for managed Kubernetes offerings, such as AKS and GKE. Usually, they manage the control plane for you at free of cost, and they charge you for the cluster nodes and the workloads that you bring into the system. And the control plane, what they manage, is in their subscription. And your worker nodes and the workloads are in the customer's subscription, that is your subscription, which are in the completely different network. So how do we bridge that communication? So what it says in this diagram is that API server is the component that almost everything talks to, with the exception of etcd. Everyone talks to API server, whether it's kubelet registering itself as a node, talks to the API server, whether you have a pod running in your workload that wants to talk to the API server. The idea being that the API server is the endpoint. However, the API server needs to talk back to the cluster network too. In cases where you need to kubectl exec, kubectl logs, port forward, and proxy. In such cases, the communication happens from API server to the cluster nodes. Now, this is where the API server network proxy comes in. As you can see, I have provided two components, connectivity server and connectivity agent. The agent is a deployment or daemon set that resides in the customer's network, and the connectivity server is a component that resides in the control plane network. The agent establishes a long-running gRPC connection with the connectivity server. So it's not like connectivity server trying to establish the connection. Mind you, it's a bidirectional connection, but it's the agent that says, hey, I'm here, and I can route the proxy traffic for you. The connection between API server and connectivity server can be either gRPC or HTTP connect. So there are multiple strategies that connectivity server supports, such as default strategy or destination host strategy or the default route strategy. We'll talk about it more in the demo. But the idea is that there are two components, one residing in the control plane and one residing in the customer's network. So how does this work? We define a new kind egress selector configuration. The name is either cluster, control plane, or HCD. It means what sort of traffic you want to proxy. Cluster here means I want to proxy all the cluster-related traffic by the connectivity server. If it's HCD, then I want to proxy all the traffic that is related to HCD via proxy connectivity server, or the control plane. The proxy protocol is gRPC. As I mentioned, it's either gRPC or HTTP connect. And the transport protocol that we want to use, either it would be a UDS socket, Unix domain socket, or when it's UDS socket, it would mean that both the API server and the connectivity server are in the same network. It could be same pod, but the idea being that they are in the same network. But if it's not UDS socket, it can also be a TCP connection. And for that, you'll need to establish the MTLS between the API server and connectivity server. The egress selector configuration. So in order to let the API server be aware of this new configuration, we need to pass it in the egress selector config file flag. And the configuration that we would create would then have to be created as a config map and then mounted as a volume. Standard procedure for loading configurations. Right. So I want to share the demo on how we are going to, the communication is established. So on this side of the terminal, I have the proxies. This is not related to Kubernetes at this point of time. I'm not using Kubernetes. I'm simply showing two binaries, proxy server and the proxy agent. I have the proxy server. I'm connecting it in HTTP connect mode, and I'm providing the server certificates, one which it should start up with. And the proxy strategies are destination host, default route. Let's fire up the server. Okay, so server has started. On this side, I will start the agent. The agent I have over here, it will use the certificate so that it can establish the MTLS connection between the connectivity server, and the agent identifier that I'm using is http-bin.org. What that means is this agent can only route the traffic for http-bin.org. Any other proxy request that comes through this agent will not be routable. And I can do that because I am using the proxy strategy, destination host, and default route. So destination host would be like, okay, an agent would identify itself as, I can route these particular domains, these IP addresses for you, but not others. So over here, this agent says, I can only do it for HTTP bin. All right, so the agent has started itself. As you can see, it's tried to connect to this server, which is the server ID. You can see, it received a connect request from agent, and it has registered that agent. Now, this is just a test client that would try to make an HTTP request to http-bin.org via proxy. And it should succeed because I am requesting http-bin.org. Better? Is it better? Okay, I'll rerun it again. So as you can see, I was able to reach that endpoint http-bin.org, and you can see the logs flowing in from here. So what happened was the test client made a connection request to proxy server to get to http-bin. Proxy server sent the request to connect proxy agent, and the agent made an outbound connection to http-bin.org, and then the data was flowed in a reverse manner and out to the terminal, giving the HTML output. But if I do, let's say, for example, instead of http://bin.org, if I do example.com, it would fail because I'm using proxy to connect to example.com, and when it reaches to the connect proxy server, it does not have an agent that it can route to for example.com. However, if I was using the default proxy strategy, if I had, okay, let's use default proxy strategy, that means that I can route it for any type of connection, any type of domain that you want me to. And if I do that and do example.com, the test line, I was able to reach the example.com and I can get the output. This is not involving Kubernetes at all. Now let's take a case where we are using Kubernetes. Okay, so I have created an AKS cluster over here, and if I can get the logs, ready? Yeah. Okay, so I have my cluster where, as you can see, I have 2 agents running in this, and this is the AKS cluster that a customer would have on that when they create their cluster. And this is the control plane that is managed for you by AKS. So in this, as you can see, there's connectivity server running, right? And you also see where I can see. I also have connectivity agent running in the control plane. So what I'm trying to do over here is that I have 2 different sets of agent, one in the control plane network and one in the customer's network. So when the requests come from the API server and I have provided identifiers, agent identifiers, that it should be for the internal connectivity agents, then the request would be routed to the agents in the control plane. If it is customer traffic, if it is for the customer network, then the proxy server will choose the agent that is in the customer network that we just saw earlier. Okay, so this is the connectivity agent logs that it is right now. So if I try to do the logs of the Nginx pod that I'm running, it is routed via the connectivity agent that we have running in the customer namespace, customer network. So the idea behind here is that it is wrong to assume from the customer API server perspective that both the networks will be in the same IP routable network. And if that's not the case, we need to find a way how to bridge that communication between the control plane and the customer's worker nodes. And API server network proxy is a project that does that. So at this point in time, I want you to join us. Come to a project meeting. It happens on alternate Wednesdays at 10:30. I know it's kind of late, but it's either 9:30 or 10:30, depends on the DST. And you can help take this forward, the project itself from the beta state that we have right now to GA. And there are lots and lots of opportunities to contribute over here and make key changes, and not just contributing superficially or making some small changes, but you can make real change because it's a critical piece of the infrastructure for the managed service providers. And there are very small group of the maintainers. So it's not like your voice will not be heard or opinions will not be heard. So it's a very a good place to start your open source journey. And I look forward to having you. If you are using this project, then I invite you to be part of the discussions. If there's a requirement at your company or something like that, and you are thinking about different options, and one of them is API server network proxy, then I implore you to check it out. Thank you. If you have any questions, please let me know.
Hello. Yeah, my question is this is valid only in case control plane is managed by Google or Amazon or somebody, and we have our own self-managed worker node environment? Is that in that case only this works?
So in that case, the proxy server project would be more importance to that managed provider, right? But as I showed in this before demo, I was not using Kubernetes. And if you have a requirement where you want isolated networks, even in your network, even in the customer's network, you want, let's say, some nodes to be isolated from some other nodes, you can use the project itself and provide appropriate identifiers and then route traffic accordingly.
So this doesn't work in case of the air gapped topic is there?
In the air-gapped Kubernetes clusters, again, you would have to tweak the settings, but it can work in a way that there has to be a connection between connectivity server and connectivity agent. If that connection is established, then you don't have your other workloads or nodes, if they're not exposed to anywhere and they're completely air-gapped, that could work. The only requirement is that the connection between the API server, connectivity server, and the connectivity agent is established.
Thank you.
Last one.
So, can you guys hear me?
Yeah.
Okay. So basically you have two agents, right? One is at the worker nodes and one is at the control plane. Right. My question is, how do you ask API server to talk with the agent in the control plane?
Okay, so it's not a requirement to have the agents in the control plane. That's one of the use cases that we had. So we have two different set of agents, one in the control plane and one in the customer's network. Ideally, it would be connectivity server on the control plane and the agents on the customer's network. And the way we can, the way API, the connectivity server selects the which appropriate agent to use for routing the traffic, it's via the proxy strategy on the connectivity server end and agent identifiers flag on the connectivity agent end, where in the agent identifiers, you can say, I can route for A.com, B.com, C.com, and the default route being false. And the other agent can say, don't send anything related to ABC, but I will be the default route as true. Send anything else for that.
Yeah, hi.
Hi.
So you said, right, we are using mainly, we are using this mainly when we have to connect through cross network.
Yes.
Right?
So as you said that we need to install the agent in the customer network and we have to have an agent in the control panel, right? So if the customer is having, like, say, multiple networks in their system or in their infra, so we will have to install as many agents as there are the number of networks there.
Yes, yes, because an agent has to establish communication with the proxy server. If it cannot identify that connection, that establish that connection, then how would that network will be routable?
Yeah, so I was asking, like, if we can have a central this thing as the centrals configured at the customer point, so they won't have to install multiple of these agents in their different networks. So if that, like, there are 3 different networks, these can access a central point, and from there it can navigate like that.
Then there has to be a way where at the central point where all the agents would establish that connection. And so from the server's perspective, proxy server's perspective, it would still have that one agent, the central location. But then there would have to be a way where when the traffic from, let's say, kubectl logs, it reaches the agent, the central location, it would have to be, how do I route it to the appropriate network out of these 3 agents that I have? There would have to be some functionality built in either into the agent or some external application which could make that decision for us.
Thanks.
Oh, yes. So connectivity or the API server is the default choice of tunnel implementation for the AKS and GKE. So if you have a cluster in AKS, there is a 95% chance that you are using connectivity as the tunnel implementation. Previously, there used to be SSH tunnels. After that, it was like OpenVPN tunnels. But then all the projects have shifted to, all the clusters have migrated to connectivity. And I am sure that GKE also uses it, IBM also uses it, because those stakeholders, they take part in the meeting, the discussions for the project meeting, and that's where I get that information. No, so if you are using kubectl, any client has to go through API server, right? The API server, armed with the information in the egress selector configuration, would have the knowledge of, I want to, if it's cluster-related communication, then I need to route it to this particular UDS socket, or it's a TCP endpoint. In my case over here, I had connectivity server as a deployment and connectivity service. So the egress selector configuration would represent the URL of the connectivity service. And then when it reaches to connectivity server, the agent, the server would make a decision based on the agents it has connected as to where it should route the traffic to.
So, please continue.
Yeah.
So, what of the over that what of like that?
No, there are no changes. It's basically simple gRPC connection, a long-standing gRPC connection between the agent and the connectivity server. So the gRPC routes then multiplexes multiple TCP connections within that one single gRPC connection. And the API server and the connectivity server have either HTTP connect or gRPC. So we are not touching any IP table rules or anything to get this working. Yes, you had last question, right?
Thank you. So I wanted to get any hints of the performance, the throughput that you're getting. If are there any measurements or benchmarks done?
Okay, so the project does have performance benchmarks. There hasn't been any noticeable drop in the fleet of AKS clusters that we have, a noticeable drop regarding the throughput of the agents. The best thing is that you can sort of, I had 2 agents, if you saw on the overlay cluster, I had 2 agents. That can be configured and I can say I have 5 agents. So you have 5 different lines of establishing connection from the connectivity server and the agent. So you can sort of get that extra agent if you are feeling the pinch of the traffic.
I think that brings us to the end of the session. Thank you so much, Imran, for such a great session. And yes, I can see that a lot more people had questions. I would encourage you to engage with Imran during the networking sessions, right? And ask him those questions directly. In the interest of time, we'll have to move to the second talk, right? So the second talk we have today is resource usage tracking for data and AI ML workloads. It's by Manikandan, right? From Cloudera.
My name is Mani. I work as staff engineer in compute platform team at Cloudera. I'm also the member of Unicorn PMC group. Today's topic is resource usage tracking for data and AI workloads with Apache Unicorn. Anyone tried Unicorn before? Anyone heard about Apache Unicorn? Okay. Let's look at the agenda for today. Introduction. We will discuss what is Unicorn, why did we design Unicorn, and what it does for batch workloads, and so on and so forth. Then we'll look at the quotas. Quotas. So what are the different ways that you can have the queues, and then what are the limits that we can impose on as a quota? How do we capture the usage for each queue and things like this? And the third one is tracking resource usage. So we want to know how much each queue has used and how much applications has used, and then how much node has used, what is left out in the nodes, and things like this. And finally, we'll take a look at historical resource usage. Finally, and then after that, we'll move on to the QA if the time permits. All right. Apache Unicorn. Unicorn is a scheduler for Kubernetes, and it works well on on-premises as well as public cloud setups. So before look at why did we design Unicorn, let's look at the limitations with the Kubernetes default scheduler. So if you look at historically, the Kubernetes has been designed for service type of workloads. So what we are trying to do here is, we are from Yarn background, and then we are trying to see how we can able to come up with some scheduler which can cater any type of workloads. It could be either service workloads or batch workloads, in general, any type of workloads. So in general, if you look at the batch workloads, most of the time it can have more than one part. So for example, there could be a set of applications which will pull the data from some sources, and it will do some ingestion activities. And there could be other set of pods which might be processing the data. It will do some other massaging and things, and so on and so forth. And there could be other set of pods which might be consuming the processed data. It might be dumping it to some other S3 or databases, and so on and so forth. So if you look at this nature of this kind of applications, what we need is, we need something like queuing. So we can't have a situation wherein when the user is trying to submit the third pod and it gets rejected at the submission level. So in the Kubernetes, what happens is, when you're submitting the second pod or third pod or fourth pod for to do any kind of work, it gets rejected or it gets denied when you don't have the resources available in the cluster. So that's what we are trying to do here. So in those cases, the user has to do some retry logic, and then he has to keep on trying it until the resources becomes available in the cluster. So that is a major pain point with the default scheduler setup. Whereas in Unicorn, what we do is, we don't reject the request then and there. We just accept the request and we put it in the queue. So that's what we call it as workload queuing. So no rejection, no denial at submission times. It gets accepted, it just being queued, and then it will get processed as and when the resources are available in the cluster. So if you look at this diagram, so on the left side, you have a different number of queues, wherein many users have submitted the pods of different nature. Each color denotes a different type of job. On the right side, you have a bunch of nodes where Unicorn sits in the middle, and it will try to place the request accordingly on each node based on multiple factors, which will be playing an important role in the scheduling. Gang scheduling. Next one is gang scheduling. People should be familiar with the Spark kind of an application. So if you look at this nature of an applications, usually you'll have a driver and the executor. So it's not only the Spark. Even if you look at some of the TensorFlow jobs or MPA workloads, you need certain combinations. You need a launcher plus worker, you need a driver plus executors. So that's where this kind of an application makes sense. So what we do here is we treat them as a gang, meaning group of pods, and we ensure that the job will start only if the resources are, certain amount of resources are available. So what it means is, let's say if the user is submitting the Spark application, and then he might say that I want to run one driver, 5 executors. So what we do here is we just ensure that the whatever the resources required for the 6 pods needs to be available upfront, and then we need to ensure that as and when they start the real pod, meaning the real executors, we will try to replace the real pod with the placeholders which we have created before. So that's how we ensure the gang scheduling has been taken utmost care with the Apache Unicorn. Third one is sorting, application sorting. So before we look at the sorting, let's look at the application. So usually Kubernetes, if you look at it, so there is no concept of applications. So people just submit the pods, it will get scheduled and move on. So, but most of the time, if you look at the batch workloads, we can have multiple pods. So application is nothing but the logical grouping of more than one pods. So if you look at the nature of any data processing jobs, there could be n number of pods. It could be one. It can vary up to hundreds or thousands. So that's what we call it as an application. So repeat, it's a logical grouping of pods. And the most important thing here is there could be different varieties. For example, you might have a data processing jobs which can run daily, night, or weekly basis, or monthly. It can be in that nature. So, and moreover, one more important point here is these jobs can run one after the other, meaning the first come, first service. So that's kind of a nature. Whereas if you look at the other set of use cases, for example, the data science team using the system during the daytime, it's more like an interactive nature. So let's say some 5 people are working in the data science team, and then if they want to use the system, we need to make sure that the scheduler provides a fair amount of resources among these 5 users. So that's what we call it as fair sorting. So in Unicorn, what we do here is we can set up multiple queues, and each queue with a different application sorting algorithm. So you can have a queue, one with fair, the other one with FIFO, and things like this. So, and in addition, we can also have a priority-based sorting. So in Kubernetes, that's how the default scheduler works. People submit the jobs, it gets sorted based on the priority, and the scheduler picks it up, and it will take it forward. So here, you can have a different combinations. So the other inspiration or the background that where we are coming from is Apache Yarn. So if you look at the Yarn and Mesos, people are familiar with the queues, multiple hierarchies and quotas and things like this. So we have taken the same concepts from those background, and then we applied it into the Kubernetes using the Apache Unicorn. So if you look at it here, what we are trying to do here is the resources mostly live in are managed via the queues. So queues is nothing but a bunch of resources available for you to operate, and then you can submit the pods to any queues that you want, and then scheduler will pick it up, and then it'll just take it forward. So there are two types of queues. One is auto-created queues, and then the other is the statics. So it's not necessary that you need to create the queues always upfront. You can create it on the fly as well. And then the scheduler will make sure that it will place the pod and those queues via the placement tools. And the other set of queues are static queues, which needs to be created upfront, and then it is of fixed in nature. And as I studied before, usually the resources are located in the leaves. So if you look at the diagram, whatever it is being displayed here, you have the root, and then you have two different set of queues, data engineering and data science. And below data engineering, you have two different set of queues, data ingestion and data processing. And under data science, you have a machine learning set of tasks. Yeah. So usually, if you look at it, so the resources are located in the leaves. So the main important role of having this parent and then the root level is to make sure that we aggregate the resource usage and then the enforcement. So which I will be discussing more in the next slide. And yeah. So quotas. Quotas are the base through which one can able to set the limit for the queue level. So for example, let's say if I want to allocate 100 gigabytes of data, 100 gigabytes of memory, and then 100 picos to data ingestion, all I have to do is I have to set it in that way for that particular queue. It's not necessary that we should set we can set the quota only for the leaves. We can even set the quota for parent and also the next level of parent, the next level of parent, all the way up to the root. It's not that only the quotas can be set for the queues, it can also set for the users and groups. For example, what happens is, let's say in the data ingestion queue, there could be different set of users, there could be a different set of groups. The users belongs to the groups. You can also set the quota for each users individually and also for the each groups as well. So that's what we meant by also for users. And in addition to setting the quota, we also need to do the enforcement, right? So what happens is, let's say if there is a quota has been set at different levels, and what happens if the usage exceeds those limits? So we need to make sure that we are applying it in all the levels, not just only the leaf queues, being applied in all the levels all the way up to the root. So let's look at it using an example so that it will be very clearer for you. So this is an example. I just took it from the previous slide. So the same example, you have the root, you have the data engineering, data science, and under data engineering, you have data ingestion and data processing, and under data science, you have machine learning. So this is different queues that you have, and then you can create as many queues as that you want. You can go as deep as you want. So if you look at it, there are two pods running in the data ingestion queue. Each one is using 10 GB of memory and 1 CPU. And if you look at the machine learning team, the same thing, there is a pod which is using 10 GPU. So this is the setup that we have, and then 3 pods are running in the system. And based on the pods which is running in all the leaf queues, if you look at it in the parent level, the data engineering, the usage gets aggregated and then it's summed up. So the 2 pods, so it becomes 20 GB and 2 CPU in data engineering. Whereas in data science, it's just only 1 pod, 10 GPU. If you just go one level up, and if you look at the root, it's a summation of both data engineering as data science. So that's how we aggregate the usage all the way up to the root in all the levels. So now let's try to apply some limits and see how it works. So root, usually we don't control it because we need to make it as flexible as we want, because if you look at the public cloud setup, the clusters can scale up and down. So the root resource limits are usually based on the number of nodes running in the cluster at that particular point of time. Because let's say if you are adding one node today and then it has to change accordingly, and if the node gets removed, it has to decrease accordingly. So that's why there is no resource limits which we can be able to define explicitly. So it's automatically being derived from based on the number of nodes. But we can set the limits for other quotas, other queues. And for the data engineering, we have put the limit as 60 GB and 4 CPU. So that's a limit that we have imposed on that particular parent queue. But if you look at the usage, only the usage is kind of underutilized, and then we can see a lot more pods coming up. So now there is a new pod coming up in the data processing queue who needs 10 GB of memory and 4 CPU. But if you look at the usage in the parent level, though we haven't defined the limit on the data processing queue, but there is a limit on the data engineering parent level queue. So that limit will get imposed for the leaf queue, which has been created underneath. So if you look at the usage and the limit, if you add this 4 CPU to the usage, then it will become 6 CPU. But if you look at the limit, we have only the 4 CPU. So that's how we do the enforcement. There won't be any excessive usage of the system, and then it will be in control. And this is how we can be able to achieve multi-user and multi-tenant kind of a system, wherein you can be able to create separate queues for each individual teams in your organization, and you can enforce the limits accordingly, and no one will get disturbed because of the other tenant. So that's another thing. Tracking resource usage. So what are we going to track here? So what is happening here? So we are running pods through the concepts called applications. So what we need to do here is we need to track the application. We need to track how much it has used so far. And then we need to know what is left out in the queue, and that too in the different levels. And we have the nodes on the other side. We need to track what is left out in the queue, nodes, and then how much each node has used so far, and things like this. So this is what we call it as tracking. So without knowing this information, the scheduler cannot work, because using this information only, the scheduler can able to decide and dare to place the pod on which node, right? So that's what we call it as tracking. And we do the tracking as part of the scheduling cycle. So what is scheduling cycle? So if you look at the Kubernetes, in Kubernetes world, there is only one, meaning they don't have the concepts called queues. There is a namespace. It's more like in one single flat queue. When people submit the pods, it gets into the queue, scheduler picks it up, and then it takes it forward one by one. So they won't be, meaning there is no way that you can able to configure multiple queues with the different set of use cases. So here, as I said before, we can have multiple queues based on your use cases. So now, if you look at this diagram, this is the diagram which explains how the scheduling works in Unicorn in a simpler words. So what we do is, we look at the queues, meaning there could be more than n number of queues. So what we do is we just do the sorting of queues, and we pick the first queue based on the sorting algorithm. Even for the queues, we have the sorting algorithms. So once we have chosen the queue, what we'll do is we'll just look at the list of applications pending in that particular queue. And once the application has been chosen based on the algorithm, it could be either FIFO or FAIR or priority, etc., etc. So once the application has been chosen, what we have to do is we'll just look at the pending request. So what it means is we need to look at the pending pods in that particular application. So that will get picked up one by one, and then we will try to do the try. We will try to find a suitable node. So again, to choose a node, we use a sorting algorithm. For example, if you look at the public cloud setups, we need to ensure that we first fill up the nodes one by one, so that you don't have to spend money unnecessarily on the remaining set of nodes. So we have an algorithm called bin packing that probably people can use it for public clouds, wherein for the on-premises, people can go for the fair, because you have a definite set of nodes in your cluster. You can just fill the nodes based on the fair usage. We just look at the usage of each nodes, and then we place the pods on the nodes based on the fair amount of usages. So that's how you can configure various node sorting policies as well. So now let's say some node has been chosen for that particular request, and once the allocation has been done, what we need to do is we need to track it. So the tracking here is the current state. Which queue the request has arrived, and what is the application, and which node it has been placed, and which user has been placing that pod. Does he belongs to, or does she belongs to any group, and things like this. And also, it's not just this information. The information has to be compiled in the usage level, right? So how much the usage has been done so far in the queue, how much the application has used it, how much the node has used. So this is what we call it as current state. So if you look at it, this current state is like it moves very dynamically, because a scheduler picks a pod, it places it on some node. Again, the state changes. Again, next thing, next pod, and it goes in this way. So this current state itself, it's very dynamic in nature, and it has to be very fast, and it comes from various sources as well. So this is how the scheduling cycle works in Unicorn. In addition to the scheduling cycle, there is another set of offline things, which I am calling it as finished allocations. For example, internally, what we do is once we have placed the allocation on one particular node, we get some information, we get some communication from the node saying that it has been done. So that is something that we process asynchronously, and that also will get tracked and as part of the current state information. Yeah. So let's take a deep dive into the data that what we want to do here. So if you look at it, so that the five the important entities here is, the first is a queue, and after that there is an application, and there is a node, and the two entities are this user and group. If you look at the quotas, it's hierarchical in nature, meaning you can create as many levels as you want, as deep as you want, and then it's not mandatory that one can impose the limit always on the queues. Either it's up to the users or the administrators to define or configure the quotas, or if you make it open, it will just work accordingly. So what we are trying to say here is the usage will get tracked irrespective of whether the limit has been set on the queues or not. But in case of applications, we do the tracking because how many number of pods, what is the memory, and CPU and GPU, and so on and so forth. If you look at the third entity, the node, here, unlike the two other entities, this is something that we have to be treated in a slightly different way, because you cannot have a situation that wherein this can be flexible. For example, it cannot go up the available resources the node, because node available resource is fixed, and it's a piece of hardware, right? So you cannot have this kind of a flexible nature when it comes to the node. So that's what we are trying to say here by it should always fit in the available resources. Historical resource usage. So before getting here, let's recap whatever we have done in the previous slide. So I told you, right? So Unicorn Scheduler cares only about the current state. It doesn't know what has happened 5 minutes before, or a week back, or a month back. So all it knows is the current state. It makes a scheduling decision based on the current state. That's it. So, but if you look at the way the Unicorn has evolved over time, there are many customers, and then there was a need that we need to provide the historical information as itself. Like, for example, if people are familiar about the yarn, in yarn there is something called called an application server, which will try to provide the historical information over time. You should be able to know like which user has used the system the last month, how many number of applications got success, completed, failures, how many keys was there before, a week back, and so on and so forth. Yeah, so that's the historical information. So now, if you look at the one of the principal design in the unicorn is like we want to be like stateless. We don't want to keep or we don't want to persist any information in any other storage layers like databases or S3 or something like that. So that is what, because of the performance reasons. So when we say stateless, it's mainly for the performance reasons. And if you look at the other important bottlenecks in designing this kind of an historical system is because what happens if the unicorn restarts? How do we identify whether the restart was happened on last week or last month or 2 minutes back or 5 minutes back and so on and so forth, right? So what we do here is we can able to identify the instance at least by creating some dynamic ID. And one more important thing in this kind of a setup is the nodes are usually known by names. So for example, you can create 2 different clusters and you can have the same node name. And also the same thing goes for the application ID. Typically in the Kubernetes, people can create the cron jobs with the same set of application IDs over time. So this kind of things are reusable identifiers. So we need to address the problems because of this kind of an reusable identifiers as part of the historical research usage system and configuration. So queues queues are available today, but it can get deleted in the next moment, and quotas can change. It's not just get it changed only at the current time, what happened yesterday, what was the quota last week, and things like this. So let's look at the slides at the very first. We have 2 more slides. So what we have done here is we have designed an event system, which will take care of pushing the events as and when the things are happening, and then so the people can consume the event as and when the things are happening using this event system. So that's what we have created here. So let's look at quickly how it is fitting into the current scheduling cycle. So I'm just running my slides because the time is up. Yeah. So this is the final diagram I would like to show it to you. So the event system, whatever we have built it, you can make it from this diagram like how it is fitting into the existing scheduling cycle. The same scheduling cycle diagram that whatever you have seen before is even here. If you look at the first part or the first half, you can make how the event system is fitting into this whole scheduling cycle. So even if the configuration changes happens, if there is a queue changes, if there is a request changes, the state changes for the application, everything will be triggered as an event that will get passed through the event buffer, and then there is another side through which it can get exposed via the REST API. So this is how we are providing the historical resource usage for the clients. We have 2 APIs. One is batch, the other is streaming. The batch is all about pulling the limited set of events, whereas the streaming is like you can connect to any HTTP connection available in our web server, and then it's a separate Go routine. It is like you can, because of one inactive client, the other clients won't get affected. Meaning the clients can consume the events as and when the things are happening. And that's how we can able to build the external systems later. So these are possible future enhancements. So which you would like to do, like storage and things like this. Yeah. I'm done.
Thank you so much, Mani. If there are questions, I think we can take 2 questions. So yeah, 1 second here and there. Welcome.
Yeah. Hi. Thanks for the nice talk. So let's say if we want to use the regular Kubernetes without unicorn, then maybe like namespace limit setting, that is the way to go, right?
Yes, you're right.
Okay.
So what we are trying to do here is, we are trying to replace the default scheduler with Unicorn. So it has a lot more capabilities. The performance is a lot more better. You can try it out and see.
So another like question. So if we want to deploy the unicorn scheduler, so we have to disable the Kubernetes scheduler and then
Need not to be. You can run along with the default scheduler, but however, we don't recommend that setup because there are chances that we have seen in the customers' deployments, especially with the Apple, that it's not in the sync.
Makes sense. So one more question like related to same thing. Is only unicorn scheduler is the one component, or is there any agent or something else that also?
Actually, I haven't explained the architecture. If you look at there are multiple components involved here.
Okay.
We can discuss it offline if you want.
So my question is not really technical, but like I understand that Unicorn was originated at Cloudera, right?
Yes.
So what decisions then made you to choose to go towards the Apache side and not donated to the CNCF side?
I remember discussing the same thing with my manager, who is Sunil. So if you look at the Cloudera background, so mostly whatever the projects that we have created so far, we are from we submitted to the Apache community. So that time, actually, I was not there. I was not a Cloudera employee then. But what I heard from the other folks who are involved at the earlier stages, like it was, meaning there is a mixed thoughts from different set of people. Like some people want to go for Apache, some people want to submit to the CNCF. But then they said that let's go with Apache because of the background. That's it.
Thank you so much, Mani. Can we have a round of applause for him, please?
Thank you.
So we are arranging for the snacks, but before the snacks, I think while it is being arranged, I think we can get done with one more talk and then break for snacks and a networking session, then come back for two short talks after the break, right? So next up, we have Amog and Satya from Cloudera. So they're going to be talking about scaling Apache Airflow data pipelines towards enterprise journey using Kubernetes, right?
Okay, yeah. So good afternoon, everyone. I'm Amok Desai and he's Satya Naik. And we'll be talking today about scaling Apache Airflow data pipelines towards enterprise AI using Kubernetes. So before we start, I'd like to give a very brief intro about us. So I'm Amok. I work as a senior software engineer at Cloudera. I bring in about 3 years of industry experience here. And I mainly work in and around Cloudera data engineering. So Cloudera data engineering is a tool that empowers data engineers to onboard their Spark and Airflow operations at scale. And this onboarding happens to an auto-scaling Kubernetes cluster. So apart from my day job, I spend significant time with open source. And I also serve as an Apache Airflow committer. And this is for close to 6 months now. And yeah, I've delivered a few talks at a few local summits and also at the Airflow Summit 2023 in Toronto. Yeah, apart from my work, I'm an avid sports lover and I spend my free time watching and playing sports.
Hi everyone, good afternoon. I am Satya Sundar Naik, working as an engineering manager in Cloudera. So I work in a team called Cloudera Data Engineering, which Amog has already briefly explained about. So I have around 19 years of industry experience with respect to fintech, gaming, big data analytics, and Kubernetes. I am a fitness freak, sports lover, and as well as avid reader. Thank you everyone for joining with us. Over to you, Amog. Please start.
Okay, so moving ahead, before we jump into the topic today, I'd like to again touch upon why Airflow is so popular and widely accepted in the industry today. So it's far ahead of its alternatives due to a few factors, such as dynamic workflow orchestration. So Airflow allows for dynamic and flexible workflow orchestration, and this makes scheduling and management of complex data pipelines easy. It's highly extensible. It offers a rich ecosystem of operators and hooks. And if that's not enough, you can always extend the functionalities by creating custom ones.
The DAGs can be abstracted using Python here and not by config files, which makes it easy to express and visualize workflows. Airflow already has a seamless integration with various big data and AI tooling. It supports dynamic parameterization. So users can basically parameterize their DAGs and tasks using Jinja templating. This allows for reusability of workflows. Then comes the task dependency system. You can manage tasks also using Python. And this enables users to express complex relationships with a lot of ease. And yeah, what we are interested in here, scale. So Airflow is designed to scale horizontally, and it makes it quite suitable for large data scale processing requirements. So yeah, due to these benefits, right, we use Airflow at Cloudera quite extensively, mostly in a cloud native deployment. So it's it's part of our proprietary offering, Cloudera Data Engineering. In short, we offer a managed Airflow here for better integration with Spark and big data processing within the Cloudera ecosystem. Then we also use it for our internal use cases, such as the daily QE regression runs, where we run data service integration tests, then DAG-driven upgrade testing. This is basically platform testing in, let's say, a multi-hop scenario, where you're upgrading from n-2 to n-1 to nth version of a particular platform. And lately, we've been using it for build promotions as well. So, okay, that's not visible. Let me open it in the UI. So, yeah, this is one of the example DAGs that we use. This is used by the interop E2E team. So this is, yeah, you can see it has quite a bit of nodes, right? So yeah, I don't want you to focus on the nodes, but the general structure of it. So this is one of the simpler ones that we have, and a slightly more complex one. So this is kind of the scale we are operating at, operating Airflow at. Yeah, this was the second one. Okay.
Thank you, Amog, for a brief overview about Airflow. However, I am going to cover why Cloudera leverages Airflow with Kubernetes. So Airflow itself a powerful scheduler, but Kubernetes brings the best out of it. There are various factors due to which Airflow and Kubernetes are gaining popularity. These are the below factors. Dynamic scaling. Kubernetes allows dynamic scaling of Airflow workers. This means that number of workers pod can automatically scale up and down based on the workload requirements. That ensures optimal resource utilization and faster task executions. Then multiple deployment approaches. Single Kubernetes cluster for both Airflow engine or scheduler and executors in case of smaller workload requirements. In case of huge workload, different Kubernetes clusters for Airflow engine or scheduler, and another different cluster for executor, so that the customer can scale the cluster as per the resource requirement for scheduling and computing. Next is container orchestration. So container orchestration, here Airflow tasks can be executed in a container within the Kubernetes pods. This enables a consistent and isolated environment for task execution. That was an issue with native Celery workers. Each task runs its own pod and preventing resource contention issues and bad tenant issues. Next is service discovery. Kubernetes service discovery mechanism allows Airflow tasks to communicate with other services within the Kubernetes cluster seamlessly. Secrets management, mostly you guys are aware of that. Kubernetes secrets management can leverage to store and manage sensitive information required by Airflow. Restart policies, Kubernetes provides configurable restart based on the Airflow worker pods need. Apart from all these benefits of Airflow with Kubernetes, we have few challenges. Main two challenges are NFS bottlenecks and multi-tenancy. NFS, as NFS you guys know, can become a single point of failure. If the NFS server goes down all the pods relying on the storage might be affected. To mitigate this issue, we need to ensure that high availability and backup storage for NFS services should be provisioned. Performance issues. NFS is definitely, since the file system in the network is not as highly performance oriented in comparison to local file systems, especially in the scenario of high I/O requirements. The network latency and throughput of the NFS server can become a bottleneck, impacting the performance of the application. In case of multi-tenancy, as our friend Mani has told, Kubernetes default scheduler have limited multi-tenancy and resource quota management support. However, our Apache Unicorn and advanced resource scheduler can manage scheduling, advanced resource quota, and priority management with Kubernetes clusters. That will be seen in the upcoming demos. And with respect to storage point of view, Airflow requires multiple storage components such as NFS, MySQL for the database, and local storage to store tags, metadata, run history, and logs. As a general practice, we suggest to get a persistent volume mapped against a NFS or EBS or some kind of cloud storage provisioners. The volume of tag folder is shared between schedulers, workers, and other relevant components. And the metadata are stored basically mostly in the persistent volume, and MySQL DB can be part of the Kubernetes cluster as well as it can be outside of the Kubernetes cluster. As we have scale issues I have told in the NFS, we have replaced the native storage classes such as SafeFS for OpenShift and long-run storage classes for RKE. Over to Amog for a deep dive into multi-tenancy.
Okay. Okay, in terms of the multi-tenancy story here, I'll speak about what is widely accepted in Airflow as of today, and later I'll add to our additions. So yeah, Airflow already has a built-in RBAC system. This allows administrators to define roles and assign permissions to users or groups. So this RBAC ensures that different tenants have appropriate level of access based on their roles. Separation of environments. So as we are all aware, it also provides a concept known as namespaces, or it's known as environments in context of Airflow. So this separation helps in avoiding conflicts between different tenants. Then Airflow also supports connection pools. So this allows admins to control number of concurrent tasks for a specific set of connections. And these pools are very helpful in preventing one tenant's task from monopolizing resources and ensuring fair resource allocation. In terms of our addition, piggybacking on Manikandan's talk, we have replaced the scheduler, default Kubernetes scheduler with Unicorn. So one reason is that Kubernetes is not scheduler is not best for burst workloads, as we call in Airflow, and integration of Unicorn gives us few more benefits as well. So it's a better option for batch or burst workloads. Then it offers the concept of hierarchical queues, which we leverage, and it also offers the concept of defining resource pools per virtual cluster, so that the resources are restricted per virtual cluster and no malformed job can hijack the whole cluster here. Yeah, through Unicorn, Airflow is introduced even to multi-tenancy and preemption capabilities. So we do not use Kubernetes preemption here because it happens only during the scheduling cycle and not at the runtime. So the idea of preemption is quite simple, right? It's basically that the scheduler will claim resources from lesser critical applications and allocate it to the critical ones. And this critically improves the cluster utilization. So in that aspect, we define priorities for the preemption to happen. So we prioritize the core pods the most, followed by Spark drivers and Airflow workers equally, because we want, actually this is supported by Unicorn, which is known as app-aware scheduling. The reason for this is we do not want Spark drivers being killed, leading to the application failing. So we target the executors here and we prioritize it the least. This is because we don't want critical airflow schedules getting skipped because of this reason. And if they can just take the resources from Spark executors and proceed. So I do have a demo. So let me quickly reshare. Okay, so coming to the first demo. Is it visible? Okay. So yeah, first demo, I'll be touching upon the resource quotas. So yeah, this is our CD UI. I'll try to show you a few details and jump to the important points. So yeah, coming to the configuration, I have defined, okay, I'll just zoom in a bit. Okay, so I have defined a few parameters here, which is the guaranteed and maximum CPUs. We need 8 cores and 24 GB in memory for CD infrastructure. So I've defined a little more for cores. I've given 9. And for memory, we need 24. I've given a little more again, which is 25. So yeah, let's see what happens. Going a little bit further, I want to show you how the queue structures look like. So this is kind of how the Unicorn queues look like now. So the top level, as Mani had shown in his demo, was root followed by default with unlimited resources in theory. And then eventually we have our tier 2 virtual cluster, which I was showing you earlier. So yeah, just click on it and we'll try to see the resources we have configured. So yeah, last screen we gave 24 and we gave about 24 memory and 25 memory and 9 cores, right? So we can see it here, but let me show you for an actual usage. You cannot see any actual usage here in terms of how much is allocated actually. So that we can see on this Unicorn UI. So if I pause for a second here, you can see, let me zoom in a bit as well. So you can see the, for the virtual cluster I'm interested in, you can see 5.6 cores being allocated with a total of 17.3 GB allocated and maximum as well below. So I'm just clicking on another virtual cluster here to show you what it looks like for a cluster that is not short on resources. It's at an occupancy of 34% memory and 28% CPU. But for our cluster, we are kind of short on the CPU, which is 62%. So let's try out a few applications here and try to show you the power of resource quotas. So I'm not diving a lot into this, but this is a simple Airflow tag. I'm creating 50 bash operators, and each bash operator, all of them are running in parallel. And each bash operator basically takes 100 millicore of CPU and 200 MB of memory. So yeah, I'm just going, I've uploaded it to my CD cluster here. I'm just going to go ahead and actually run it. So I just triggered it. So yeah, it's in a job running state, right? Now, what if I go to, okay, in the Airflow UI also, I'll actually show you that, okay, you can see, right? Yeah, most of the tasks out of these 50 are in a queued or scheduled state. So none of them have actually started properly running. In the Unicorn UI, it's, if you remember, the color was green for our queue. Now it's slightly becoming yellow because we're tight on one of the resource or both. So yeah, 84% memory and 82 are already occupied. So now what if I run like a big job, right? Like something, and let's say like a Spark job that asks for many more resources. So what does our resource quota do, right? So let's try that out. So going to my CD UI again, yeah, I'll skip the part where I create the job, but I want to show you the resources I provide. So this is a simple Spark scale-up job. I'm actually going to fix the maximum and minimum executors as 9 each. So that means exactly 9. and it's demanding for 1 core and 1 GB. So in total, this job is basically demanding for 10 GB and 10 cores, which is something our virtual cluster cannot offer. So let's see what happens. So I've triggered it. I'll go to Kubernetes console to show you what actually happens. Yeah, the Kubernetes console, I'll zoom in a bit more. You can see that the application was rejected. Why? Let's describe it, the pod and see. It'll show us a little more. So yeah, the message says the root, the queue does not have enough space to fit the application. So basically it was rejected. Now, if I again go back to my UI here and I go to the logs and I'll jump to the Kubernetes logs, we do see the same kind of error. So it's been propagated up here. So this was about the resource code demo. I do have one more on preemption also. I'll quickly skim through it. It's still visible. Okay. So similar setup, 2 virtual clusters running. My target here is on one, I'll be running Spark jobs. On the other, I'll be running Airflow. And I'll show you the preemption here. So going to the virtual cluster 1, this is intended to run Spark jobs. So I'm giving it slightly more memory here and CPU. So I've given guaranteed 10, 20 for CPU, memory 30 GB and 50 GB for the memories. So in short, it has enough space to run quite a few jobs. Yeah, going back to the other one, which is tier 2. So under tier 2, if you go to, again, configuration, I have kept it a little tight on CPU here. I'm giving between 8 and 9. And for memory, I've given 50 and 50. So I'm basically constraining the virtual cluster on CPU. So yeah, let's go to both of them. I will create jobs in both the virtual clusters. First one, VC1, I will create a Spark job. So yeah, I'll fast forward this part. I'm just creating a simple Spark pie. And this is what is critical, right? So I'll give 15 executors exactly with let it ask for 1 core and 1 GB. So in total, this job is demanding for 16 cores, 16 GB of memory. So I'll just create it and not trigger it now. And the second virtual cluster, little faster because I've shown you the DAG here. Slightly faster on this front. I'm doing nothing but creating the job here, the previous Airflow job that I showed you guys. So this is the creation part. Yeah, it's been created, right? Okay. Yeah, it's been created. So now both the virtual clusters have jobs. One has Airflow, one has Spark. On the Airflow UI, I should be able to see about 50 odd bash DAGs, all of them running in a parallel fashion. So that's what I see. Yeah, that's quite a lot, right? Lot of tasks. So now let me just open the Kubernetes console. On the left-hand side, I have the virtual cluster 1. This is the one which will run Spark jobs. And the it's recorded. It's recorded. Yeah. Sorry about that. I'm going back. Yeah, it's a recorded demo. So yeah, sorry, I cannot zoom in a lot more. But yeah, I was here, right? I was showing you left-hand side is virtual cluster 1, right-hand side is virtual cluster 2. Left will run Spark jobs, right will run Airflow DAGs. So okay, let's go back to the UI and we'll start triggering a few jobs. Okay, so now going back to the first one where Spark job is housed, I'm going to trigger a couple of runs. Let's say, let's do a couple of them. Let's do 5. So yeah, I've launched 5 runs. Yeah. Now if I go to the job runs, I'll see 5 of them in a pending state. Going back to the Kubernetes UI, I'm seeing 5 drivers are coming up. That means 5 are actually launching. The reason for 5 is we'll have 15 into 5, a lot of executors, so we can actually see things in detail. So now the tier 2 VC, let me go and trigger the DAG that I created. So I'm resuming schedule, and I am it'll be launched once I resume the schedule. So ID number 15. So back on Kubernetes, you don't have to read it, but I want you to see the color coding. So on the right hand side, you can observe that nothing will ever remain in a pending state. It will immediately go to a running state or container creating. But on the left, things are always in a pending state, and the ones that are in pending are the executors. So the reason for this, because we have given higher priority to Airflow workers than Spark executors. So basically, Unicorn is helping the right hand side run quicker compared to the left, or right is more prioritized. You can observe that by let me click on a few orange ones, and it will immediately turn to blue on the right hand side. So that's what you can observe. So this will keep happening until the point when right hand side completes, and the left hand side will eventually get resources and run to completion. So yeah, this will keep happening, fast forwarding this portion, and at one point both will be done. So I want to go back to the UI and kind of show you the logs. So for the first one, yeah, of course, all the 50 DAGs tasks have run. So we'll see 50 of them, 50 logs for one each for one task. So the first one, you can see it's a simple hello output. And if I go to, let's say 4, again, hello from bash operator. So we do have 50 tasks here. But that's not the case with Spark. If preemption did not happen, we should have seen 15 executors for each of the job, but that's not the case because preemption happened. So what do we see? In the first one, we only see one executor has run, but that means 1 out of 15 ran here. Now let's just check the other jobs also. So job number 20, again, let's see how many, 1 executor out of 15. Coming back to, let's say, job 18, maybe it's different. Logs again, and we see that 6 of them ran. So 6 out of 15 were able to make it here. So that was about my preemption demo. I would like to share back and give it over to Satya to conclude.
This is after the demo, actually, what are the future plans and what we're working right now. So mostly, as I told you, storage improvement, which is NFS, is one of the bottleneck, and that is what we are working to replace storage with a better alternative, such as some kind of EBS or EFS. And the same time, debuggability is one of the challenge in the production environment. So we have Unicorn, who is giving already the fine-grained statuses of event stream for different state changes of every worker pods. So CD, which is Cloudera Data Engineering, can integrate with that part of Unicorn to get better diagnosis from Kubernetes angle, such as state changes, resource allocation problems, identifying any anomalies, etc. So moving to next one, last but not the least, basically nothing is perfect. We have few challenges still now existing in the production side, we can say. So Airflow basically parses the DAGs periodically interval. So if a customer configure a very less interval for DAG parsing, at a time thousands of complex DAGs are getting parsed, yeah, definitely it's causing a scaling issue with respect to DB. So that we are working on that. So choosing right kind of storage, as I told, NFS is a problem. We have evaluated Azure Block Storage. That also has a latency and throughput issues. That we are working on that. So defining the right priorities of all the Airflow tags, that's how can be done dynamically. So that optimization, if you can do in future, then that will use the compute resources optimally. So that's what we want to cover. Thanks everyone. We want to conclude the talk. Question answer time. Thank you.
Hi, this is Nipedra. I have a question with respect to comparison with Argo workflows. how does this product compares with Argo workflows? What are the pros and cons of using each one of them, if you have idea about that?
What do you mean by Argo workflow? We are not aware of that. Can we briefly explain?
Argo workflow is another workflow engine for Kubernetes.
Okay.
So which can we can schedule the task and our other stuff with that.
Okay. Now the money is the right person. See, is Kubernetes scheduler, when we have the regular Kubernetes scheduler we have evaluated, that has the limitation with respect to resource quota management and pool management. So that is how we have come up with Apache Unicorn. So if you are talking about Argo scheduler is another type of Kubernetes scheduler, yeah, definitely we have not evaluated that one.
It's a workflow. It's not a schedule. It's a workflow in it.
Okay, yeah, even I'm not a lot familiar with Argo, but I think it's an alternative to Airflow in short. That's what you're trying to tell me.
Yes, currently I'm evaluating for ML pipelines.
Okay.
And for that purpose, I was looking at both the stuff.
Airflow versus Argo.
Yeah, correct.
Okay, it's Airflow alternative. I'm not too familiar with it, but I'll get back to you on this.
Sure.
Thank you.
Yeah, this just to continue whatever he said. Even I used our workflow, but I felt something like that is much more better than this approach, because there we have GitHub support. Here there is no GitHub support. You are changing whatever you want from the UI.
Right. Little bit. Yeah, make it good.
Okay.
Yeah.
So my confusion here is, how do you keep track of, for example, in an Argo workflow or Argo CD, at least we can have the GitHub principles. We can keep track of what we are doing, why we are doing, and everything. But here, the way how you explained is everything we can change whatever you want, runtime dynamically, just without keeping track of why we are changing, what we are changing, at what time, change it by who. Did I explain properly?
Yeah, I kind of got it. I think you're basically trying to tell that Argo has a lot more historical kind of support, but yes, the purpose is different. Argo, I believe it's for CI and...
No, we have Argo events, Argo workflows, Argo CD.
Okay.
There's so many Argo products are there. But my question is, like, I mean, the way how we are handling here is, we are not tracking. That is number one, because we are not following any GitHub principles.
No, when you mean we are not tracking, are you talking about the Airflow jobs?
No. In general, for example, if you go to your Kubernetes, I think third slide or fourth slide.
Okay, 1 second.
There is something like auto scaling. Yeah. Here only. Yeah. Dynamic scaling, multiple deployment approaches, these things, right? So dynamic scaling, how you are doing? Is it like you have a fixed number of resources before you start your workflow and workloads and all?
That's right. We have a minimum and we have a maximum limit. And
so that means you have fixed, for example, I have 3 virtual systems.
Not fixed actually. There are 2 types of form factors we have. One is private cloud and another is public cloud. When you go to public cloud, there its elasticity is there, and there is no fix.
Okay.
It can go to up to any limit.
Okay.
But whenever we spoke about the limited resource what is stored, it's basically based on the because private cloud means you have only limited resource. You can't beyond, even you can't scale it after that.
Yeah.
So we have both. If you want to dynamically scaling up, definitely public cloud you can use.
Okay, so in that case, we can schedule everything using normal labels and node affinity, pod affinity, and all such. Why do we need one more wrapper over the entire normal Kubernetes for Kubernetes concept built-in support? Whatever the Kubernetes supports, that is more than enough, I think. We do not need one more wrapper over that, then start implementing everything like redoing the same thing, whatever is already supported by Kubernetes.
yeah, I kind of get the point now. So Airflow is not a particular solution just for that. It's a general, it's not just schedule, right? It's a little more than that. It's a general solution for generally data engineering pipelines. And there's a lot of, so it's not something that we developed in-house. It's something that's been there for a while, and it offers a lot of custom operators to interact with Spark, Hive, let's say like a lot of the components for the entire pipeline. So I don't know if Argo has similar facilities, but
No. The Argo is a separate question. No, I'm not. My question is not about Argo.
Okay.
In general, for example, is container orchestration, resource isolation, service discovery. All these things are inbuilt features of Kubernetes.
Yeah, that's what I'm trying to tell you, that Airflow is doing Kubernetes because it's gaining all this. Through this slide, I'm trying to convey that Airflow, why is Airflow being run on Kubernetes in the first place?
So the statement I have told, why Cloudera leverage Airflow with Kubernetes, and this is the reason.
Okay. Thank you.
Many other things.
Okay, one last question and then we can move on to the next one.
Hi. This is related to Cloudera data engineering product itself. So like coming to the deployments of that, like do you offer it as a like marketplace in the GCP or AWS, or we can deploy it in our own VPCs, or it has to be deployed on the Cloudera managed place? Like, because the thing is that some companies have the policies that the data cannot cross the network. And if it, like, if the Airflow DAGs are written in the Cloudera's data engineering Airflow, right? So if the data has to cross the network, then it will be a problem.
Okay, sure. So yeah, this is more of a proprietary question, but I'll still answer it. We do have offerings both on, as you mentioned, right, public and private cloud. And when we say private cloud, we also support systems with air-gapped environments. So in the end of the day, it's just a installer that is sent across, right? So you can manage it on not just cloud, but even other offerings.
Okay.
Yep, so that brings us to the end of the session. Thank you so much, Satya and Abod. We have a small announcement about.
Video.
Right. Vibhav. So the next talk is by me and Vibhav, right? So we're gonna talk to you about something that has interested a lot of people. When we talk about it at conferences, we talk about the idea at different conferences to different people. Everyone's interested, everyone's asking, what is this new project that you're talking about? It's very interesting. So we decided that we'll put together a few slides and talk about running a lot of Kubernetes clusters on top of your existing Kubernetes cluster, right? So yeah, let's give us a second to figure this.
Hello, can everyone hear me at the back? Can I get a yes? Like if you can hear me? Yeah, okay, cool. So today we are going to talk about vCluster, and thank you for coming. It's pretty late now. It's a Saturday. Thank you for staying here for so long. So we are going to talk about creating clusters within clusters and more. My name is Vibhav. This is Prakash, and thank you for being here.
When we came up with this idea and on what to name our talk, Vibhav had two ideas. Either call it clusterception, because clusters within clusters, or he was like, let's call it, do you even vCluster, bro? So yeah, and then we came up with a very professional looking topic for this talk. So let's get started. I think, Humble? So yeah, we're gonna first talk about the elevator pitch for this project as to why will you be someone who would want to use this project, right? So let's talk about a real cluster versus a virtual cluster. So imagine I'm a platform engineer, right? And my developers come to me asking for, and they ask me for Kubernetes clusters to work on, right? What would I do? The usual approach is either of these two, right? The majority of the approaches fall under these two categories. I either spin up a full-fledged Kubernetes cluster for them and give them access to it, which increases the headache on the SRE and platform teams, because now I have to manage and be responsible for so many Kubernetes clusters that I've spun up, right? Otherwise, I can give them all access to one single Kubernetes cluster, tell them, hey, restrict your work to this namespace and have namespace level restrictions. But we all know that that can also get out of hand. And we just, as platform engineers, you just hope that, someone doesn't make changes to the cluster which breaks stuff for everybody else, right? So that is one place that virtual clusters actually help a lot, right? And about ephemeral environments.
Yeah, so when you spin up these V clusters, they can come up so quickly that you can just use them, or just give it to your engineers as you start using them. And you can use these for like CI/CD testing, and they come up in less than a minute. That is a big, powerful feature that they are. So you can use them for ephemeral environments. So as you start creating these V clusters in your Kubernetes cluster, have a bunch of clusters, and as multiple people start using each of these clusters, you can say that at that point, it can become multi-tenant environment. And as you go ahead, you have this fleet of clusters. You can start managing them as well. Managing them becomes easier. Instead of managing like hundreds of clusters on AWS or GKE directly, you can manage these fleet of clusters, these V clusters. Then if you have a very specific use case with your Kubernetes cluster, you can change the cluster definition. You can use templates, which are basically Helm values files. If your cluster needs specific requirements, certain operators, certain Helm charts, install them before like developers start using them. You can do that. You can spin up these clusters based on that. And if you have even more requirements, if you wanted to do, if you wanted to like work with the host cluster in certain way, so that complex applications running underneath in the Kubernetes cluster need to give some access to certain resources to the V cluster, it can do that as well. For that, you'll have to make plugins, which we'll talk about later on. Next slide. Yeah.
Also, one more thing that we wanted to mention, that vCluster is a project by loft.sh. It's a startup that has come up with this idea. It's an open source project, and we will be delving into our exploration and what we found the capabilities of this project to be, right?
So as in, before we actually, you know what, let me start with a demo. I think it'll be better for me to like introduce.
And while Vibhav starts off with his demo, right, one thing that I would want you to think about vClusters is an analogy similar to what virtual machines did to bare metal, right? You had a big bare metal server, you wanted to give it to 10 different tenants, right? And all of that. So you spun up a isolated environment for each one of them, which were your virtual machines, and you gave it to them. So now you as a person who's operating that platform is happy because they're all isolated. They'll do work which will be restricted to those virtual machines. And they're also happy because they get the full power of the virtual machine itself, right? Rather than being restricted. So the developer experience was made better by virtual machines, virtualization. And similarly with vClusters, your developer experience gets better because you as a developer now don't feel restricted, that you only have access to a certain namespace and stuff like that. You have full access to a full-fledged Kubernetes cluster, right? And your experience is as similar to interacting with any other Kubernetes cluster, just that your work is totally isolated from the other virtual clusters on the host cluster, right?
So speaking of creating virtual clusters and like getting access to it, we'll just start off by creating a new cluster. So I'm running Minikube and I'm using vClusters CLI to like create a new vCluster called new. While this is coming up, we'll go through like what components the vCluster has and then actually see them in real time. So the main components are the core DNS to manage networking between the all the pods in the Kubernetes cluster. And another is a stateful set, which actually runs the vCluster. And there are two containers. Before, Loft used to actually run the K3s as a different container. But now what they do is they copy the distro binary into the syncer container, which is the vCluster container, and run it as a process from there. And the syncer is what actually runs the K3s process. And it's basically like a controller which syncs resources between the host cluster and the virtual cluster and sees to it that the virtual cluster, works as expected.
Yes. So these are all implementation details, right? But ideally what is happening is your syncer is running as a container. It's in a stateful set. It's running as a container. And and it has access to a Kubernetes API server, local Kubernetes API server, right? So ideally what is happening is you get the kube config of this API server, which is running inside of that pod, and you're interacting with this Kubernetes cluster. What Syncer actually does is, so it has a bunch of API server, it does not run the scheduler, it strips away a bunch of controllers, right? And it runs a minimal K3s or any distribution within that process. What happens is when you create, like, let's say a deployment, right? The API server, you submit a deployment, the deployment controller now goes ahead and creates the pods for the deployment, right? But now these pods, what the Syncer is doing is it's watching all of these resources. And when a pod is created, what it does is it adds a suffix to that pod and syncs it with the parent cluster, right? So now the pod is being created onto the parent cluster, right? But to you within the virtual cluster, you're like, oh, my pod came up, right? And this Syncer manages the mapping between the names and everything, and also brings back events. So let's say the pod got killed on the host cluster, or there was an image pull backup. All of those events are also like, now synced back into the API server of this local API server. And now to someone interacting with this cluster, they're like, oh, my pod is crash looping. Oh, my pod has an image pull back off, right? So it's a very simple concept. It's a very elegantly designed project, right? So, Vaibhav?
So here we see that the credentials for the vCluster are there present over here, and you can see that they are like synced back. So if I so right now I'm in the vCluster itself. So if I go back to the vCluster, if I want to go back to the host cluster where the vCluster is installed after the vCluster disconnect, and I come back here, you can see that the core DNS pod is there. The the pod which is running the API server is there. And yeah, these are the components. So what vCluster does is, as we discussed, like it manages it doesn't exactly create a new cluster, right? It is a virtual cluster. So whatever workloads are actually created, which are the pods, they're synced down to the main cluster, and the host cluster is what hosts these workloads. And if you create a deployment or something, the deployment is reconciled by the controllers on the vCluster. So that ensures that the pod objects are met. And when the syncer sees those pods, they are now then synced below. And as you can see over here, the names of the pods are changed when they come down. It goes by the name of the pod, X namespace in the vCluster where it's deployed. And the same thing happens with services.
Yeah, and you might ask that, why sync those pods back onto the host cluster? Is because the vCluster does not run a scheduler. There is a mode with which you can run a scheduler inside of it, but the scheduler is currently stripped away. So now when it syncs to the host cluster, now the host cluster's scheduler kicks in and decides which node to schedule it on. So all of those work is totally upon the host cluster, right? And in this context, you as a platform engineer who is given 2 virtual clusters to 2 different developers, they will have their own way of interacting with this cluster, right? And all of those resources, you as a platform engineer will be happy because they can't perform anything onto the cluster itself, onto the host cluster itself. All their workloads are isolated from each other, and you can set limits on these virtual clusters as well, saying that developer A can use 2 cores of CPU, 10 gigabytes of RAM, and the virtual cluster will enforce them as well, right? So here we are touching back on one thing that we discussed earlier on the patterns that currently are used, right? So virtual cluster somewhere sits in the middle of this, right? In terms of isolation, so with giving each of your developer a separate namespace to work on, the isolation is very weak. The access for tenants are very restricted. So you have access to one single namespace, you will definitely feel restricted with certain work and everything. You'll go back to your platform team and keep complaining about it, right? And yeah, but though it's cheap and resource sharing is easy and all of these, it does have some of advantages, but the main disadvantages of having a separate namespace for each developer is that, developers feel restricted, right? And with a separate cluster, it is expensive to run. It is very hard to share these resources, and also the overhead is very high, right? So you would not want to give a complete Kubernetes cluster to each of your developers as well. vCluster somewhere sits in between, where the isolation is strong enough that they are isolated from each other. The tenants have cluster admin access within their own clusters. They can deploy, they can work whatever they want to and interact with it just like any other Kubernetes cluster. The cost is very cheap to spin up a virtual cluster. It comes up within seconds. It just pulls up the vCluster container image and runs it, and you're good to go, right? And yeah, so and the resource sharing on the host cluster is also very easy that way, right? So yes, next slide, please.
So you considering it's a Kubernetes cluster, it will need to like store its objects somewhere. So K3s was created by Rancher, and it kind of became famous because you could create a Kubernetes cluster without the same amount of resources. You could use SQLite for that. And here, when you're using K3s, you can actually set if you want the SQLite data to persist. So if you set this in the Helm values, if you set storage to persistence is true, it'll create a PVC for the vCluster. And if you pause that vCluster, scale it down and scale it back up, you'll still have that data. It'll persist. Otherwise, it'll just write it to the MTDR. And if you actually want to connect the vCluster to like a data store which you already have, like etcd, SQL even, like you can use this environment variable and connect to your DB for persistence.
Yes, you might ask that, okay, now I've created a bunch of services also inside of my cluster, right? Now, how do these pods discover which service IP these requests goes to and everything? So that's why they spin up a CodeDNS pod. And now the syncer manages to so the DNS is resolved, and this CodeDNS pod, the syncer up, it maintains a mapping of the service IP within the virtual cluster and the one external as well. So once the request is made, that on the external, on the host cluster, it goes to the CodeDNS service of that virtual cluster running on the host, from where it resolves that service's IP, which service on the host cluster is responsible, like where it should be sent to or resolved to, and then the request goes that way, right? So CodeDNS is one component that comes up along with each virtual cluster that you create. And yeah, so that's how this is a bit of overview of the networking. And yep. So yes, host to vCluster resource mapping, as we've been talking about syncer so far, this is just touching a little bit upon that. The syncer is a controller that is watching the local API server that this vCluster has created right now for certain low-level objects like pods and config maps to be created. And as soon as it sees that, hey, there's a pod that has been created, it creates a mapping from what it will name it on the host cluster, and then creates the same object on the host cluster. And then all the events and whatever happened to that pod is also synced back to the API server. So syncer kind of handles this mapping and translation, right? And it can do, downward and upward syncing of events and resources is done by the syncer. And you can also do PVC syncing in case you want persistent volumes within your cluster. If you have a storage class and everything defined on the main cluster, so you create a PVC, and I think you sync the storage classes also. When you create a PVC, it syncs it back to the host cluster, which gets a PVC attached, and then it syncs all the events back onto the virtual cluster as well, right? So do you want to add something? Okay, cool.
Actually, to make this a little more fun, so we didn't even think about what to run on this vCluster, show you the syncing. I'm just gonna run one vCluster in another and see what happens. In this case, what we should see is just the pods getting translated to the host and the services as well. So if I do a vCluster list right now, you can see that we are running the vCluster name new. So I'm gonna connect to it. Okay, now, yeah. Okay. So can everyone see the text? Yeah? Okay. No response. Okay. So we are in the V cluster now. So I'm gonna create another V cluster here. So V cluster uses Helm in the back to install this. So it's basically running like Helm install. So V cluster create cluster exception. Why not? No. See, it's having doubts. You really want to do this? I think you're okay. Yeah.
So bottom line, what he's trying to demo to you is that, how easy it is to just create new virtual clusters, how small the overhead is, and the reasons that you should be using a virtual cluster, right?
Yeah. So you can see that we were put in the new V cluster which we created inside the V cluster. Now we're going to see what the resources look like when they are synced down to the cluster below. So we switch back to the V cluster, not the new one. And then we switch back again to Minikube. Yeah. So you can see that this core DNS belongs to the new V cluster, whereas this cluster, the workload of this cluster API server that is running in the original V cluster that we created. So you can see how the resources are synced. You can see that this is the name of the API server pod. This is the name of the namespace, and this is the name of the V cluster. Yeah.
And so what he's trying to demo is that, so now we have created a host cluster, which is Minikube. We created another V cluster on top of it. And then inside of the V cluster, we created another V cluster because why not, right? And now whatever workloads were created inside of that V cluster is being synced to the new V cluster on top of Minikube. And those resources now again are being synced back to Minikube itself, right? Which is the actual host cluster. So bottom line, it's a very powerful thing. You can spin up V clusters inside of V clusters. You can spin up as many V clusters as you want. We just wanted to demo how the syncing works, and the syncer just maps. So within the V cluster, as you see, can you get the pods within the clusterception V cluster? No, this is in the new V cluster, right? Within the clusterception V cluster.
This is on the host cluster.
Okay.
This is on Minikube. So if I go inside.
So within clusterception V cluster, it will only see the core DNS pod name to be core DNS hyphen this part, right? This much, right? And all the name translation and mapping, that is handled by syncer. So that from within the V cluster, you can see a certain pod name, a certain namespace name. The syncer handles the translation and mapping of all of these resources for you, right? So next slide. If it's getting confusing because yeah, we are touching on too many aspects of the V cluster, you can talk to us after the talk as well. But now Vibhav is going to talk about one way in which you can enhance the power of V clusters for your own use cases.
Yeah. So if you have used like all the features that are already exist in the V cluster, but you want the host resources to be synced differently to the virtual cluster, or you want very specific behavior for your resource syncing and everything. Like at the end of the day, it's a controller. You can figure out what you want to do with that. You can actually create plugins for V cluster which extend it in some way. They are kind of, they're not exactly like CRs or CRDs, but think of it like as a layer where you would like to listen to the host cluster, the resources that the host cluster has made in that namespace, and then how would you want to like handle those resources once they come back up into the V cluster. So you can use plugins for that. And these are the libraries which are used usually to make the plugins. I can see that they are directly from the vCluster source code. So it will just naturally extend the existing vCluster environment.
See, a little bit about Day2 vCluster usage. Next slide, please. So you would want to also know what all can I do on top of these vClusters, right? Especially if you're a platform engineer or an SRE or whatever your use case might be. So you can set quotas and limits on these particular vCluster. And since all of these resources that is being synced by the syncer is onto one particular namespace on the host cluster, on that host cluster, you can, so basically it sets a limit on that namespace itself. So if you try to exceed that limit in terms of resource usage, you won't be able to do so. So you can, as a platform engineer or as an SRE or whoever is using your Kubernetes cluster in a multi-tenant environment, you could set limits on each of these virtual cluster as to how much CPU and how much memory each one gets, right? And there are also security measures that you can take where you can run virtual clusters in rootless mode, where no one will be able to create a pod with a root user in it. And then you also can set isolated mode, in which there will be three things, I think. There's one, pod security standards that will be enforced onto this vCluster, right? To prevent creation of containers or root containers and stuff like that. Then I think there's one more which enforces a network policy on the host cluster so that no other workload can talk directly to the API server of this vCluster from the host cluster. So you can isolate this vCluster even from the host cluster that it's running on, right? So these are some security features that vCluster provides out of the box, and also network isolation, where users who are using that vCluster can talk to anything within the vCluster and not from anything onto the host, right? And use cases, yeah.
So after discussing this, we'll come back to all the use cases that we discussed, like in the very first slide. Now you understand how vCluster can be used as like a multi-tenant environment. I think this analogy makes a lot of sense. If you have a plot of land and if you can build a independent house for yourself versus an apartment complex, it's kind of like thinking about that. Not everyone will have as much resources and everything as much as the guy with the independent house on the same plot of land has, but everyone will have a space to work in. There's it's less secure in some way, but a lot of people can fit onto that one cluster now because of vCluster. So you can have multiple clusters with just one Kubernetes cluster.
So also you can now, with the power of vClusters, manage a whole fleet of Kubernetes clusters. So this is more from the SRE point of view, where I can centrally get all the vClusters, see what's happening within them, manage all of them, kill some of them if not required. Like it places so much of power onto the hands of the SRE that now I can split my Kubernetes clusters into so many small clusters, empower each developer to do their own thing, but at the same time, enforce controls on top of it by managing this entire fleet of vClusters, right? So next slide. And also one idea that we came up with is cluster templates, right? So now there is a way where through CRDs or by implementing controllers, you could enforce cluster templates. So let's say you have team A, team B, team C within your company who all require Kubernetes access and also certain applications to be running within their environment, so that they could just swap out one or two images with their own dev image and get to working with that and testing out with that. You could also specify cluster templates where you have a template for each team, and team A gets like Nginx and a MySQL database already running with it. So the vCluster comes up, and then the cluster template is applied to that. And now me as a user, me as a developer, I could just swap out some of these images with my image, the one that I developed, and easily test out all of my changes, right? So that way it empowers developers to be brave, go ahead, use their Kubernetes cluster, don't worry about breaking it. And a cluster, having a cluster template controller on top of it, that's one thing that we were working on, is can also enhance the power of vClusters itself for developers.
Yeah, coming back to Argo CD and like Argo workflows, which we were discussing in the last two talks also, a lot of people actually use Argo applications, and each application is a vCluster, and they define like a vCluster within like an Argo workflow. I don't exactly know like Argo terminology much, but people have used Argo in the past to create vClusters in a templated basis. So it's something, if you already use Argo, it's something you can already check it out. You can probably deploy that application and test it for yourself. Yeah. So again, like with the plugins. So these plugins will like actually help you make your vClusters really powerful. One very cool plugin that I've seen is the Istio plugin, where the Istio mesh can be installed on the host cluster, but the plugin makes sure that the resources between the host and the virtual clusters are synced, all the Istio related resources. So all the status and everything is like synced back up. So the vCluster can actually use Istio without having to have Istio installed on the vCluster.
It can also use host ingress. There's a mode in which you could just install ingress controller on the host, and the vClusters also share that. Right.
Yeah. So yeah, thank you for being here for our talk, guys. It's very late. Thank you so much. Again, I'm Vibhav. It's Prakash. And these are our GitHub and Twitter accounts. And you can check out the projects over here. Thank you.
So yes, we know of currently at least 3 companies who are who have built product around vClusters. The reason we came we decided to do this talk, right? We both personally think that vCluster is a very sleeping giant kind of project, right? Where it's very powerful, has a lot of use cases that users can imagine themselves, right? Can be used in a lot of different ways, but it hasn't been discovered enough by people to actually leverage the power, right? So the first one is the link to the vCluster project itself on GitHub. The second is Vibhav's company, who works on a Uffizi cluster operator, which in turn creates a virtual cluster for you, right? You can just install the operator and create virtual clusters. And the third one is something that we came up with the idea of, that we will together work on an open source operator to create virtual clusters, because currently through Loft, you can either use the CLI to create the virtual clusters, or you can use like the Helm charts to create the virtual clusters. We just decided that it would be nice to create an operator that people can leverage to declaratively create these virtual clusters, and also the ideas that we talked about having cluster templates and stuff like that, backup and restore and migration functionality and stuff like that. These are things that we discussed one day while just sitting at Vibhav's place, and we've just started some initial work on this cluster operator. So new contributions, if you want to get involved, are welcome. So yeah, that's it. So questions?
Yeah. So I just wanted to understand 2 aspects. One is, you mentioned about network restriction or for the vCluster pods. So the network restrictions for the vCluster pods. So does it support all network CNIs, or there are specific CNIs that are supported?
I think since it's using the host clusters networking, most CNIs must be supported, right? So it's not doing anything too complicated on the network part. except for like, the core DNS, like DNS lookups and everything to discover the service IPs on the host cluster, right? So the network traffic is still flowing through the host clusters, this thing. So because we've also explored it for a short time, we haven't come across any problems on that part and all of that. But of course, there might be exceptions where, certain things might not be possible, right? You could, yeah.
So that means that the network plane and the data plane are still through the host only.
I'm been the parts of the data plane.
Okay, second part of my question is about, can we like pause all the pods or the containers in the particular vCluster?
Yeah, you can. So you can like pause it, scale it down. That's why the persistence, right? That's why the PVC, like which will actually like store all of your data in SQLite. And then when your cluster comes back up, it's back up again. One thing about the CNI, I think you can use different CNIs and also Glue. I don't know if you've heard of Glue Network, that company. They use vCluster and they test their like CNI with it.
And by pause, I mean not killing the containers.
No. Yeah.
Just pausing.
Yeah, I get it. Yeah. So scaling it down, right? Yeah. You can do that.
Hi. So similar question. Can we use with Maltus CNI?
Exactly. So that is one thing that we haven't, I think you should be able to, right?
Okay.
Ideologically, like idea-wise, but that's something that we haven't tried yet ourselves. And this is also a project that we discovered. We thought that this has a lot of potential. So we should be talking about it. Of course, there's the vCluster Slack, right? So we don't know everything about the project. We are also learning every day new things and we are building with it, right? So there's a vCluster Kubernetes Slack that you can join. And over there are a lot of, none of us work for loft.sh, right? So, but there will be people who can ask these very specific questions as to what are the things which are not supported yet and what is the future roadmap of it, right?
Okay. See,
Yes.
with Istio, I want to do any intra-cluster communication should happen directly and inter-cluster should go via egress gateway of one cluster and ingress gateway of another cluster. So between ingress gateway and egress gateway, I'll set up TLS. Those kind of setup I want to do. Then I not need two cluster, and with vCluster I can do those things.
So I did not understand your question completely, but do you want to install Istio within the vCluster?
No, basically I have two cluster and both cluster have Istio. In cluster A, I will use egress gateway, and cluster B, I will use ingress gateway, and then I will do the microservice communication via both gateways.
So ideologically, I think that should be possible, right? But again, as that's a use case that we haven't come across yet.
I don't know how Istio control plane or pilot component will get the actual name will be different from etcd and
so I
those
think
things how will manage
Istio is again within the virtual cluster, you're deploying it as a workload. So Istio doesn't really have to worry about it, just interacts with it also just like any other Kubernetes cluster. The syncer manages syncing all of the low-level resources. And if you come across a resource that you need extra synced, which you is not being done by syncer, you could implement your plugins. So that's why based on the ideology, it should be possible to install Istio within two of these virtual clusters and make all of these communications happen. But again, you don't know until you try these things, right? And this project itself is very new, right? So use cases are still being discovered.
Yeah.
And more people are trying to do stuff, as you're saying, right? Just doing this Istio.
I am interested in a very specific use case. So each cluster have a domain name like cluster.local. So how to specify a unique domain name for my vCluster? Is it possible?
Yeah, so each cluster gets an ingress, and like instead of vCluster, like vCluster.local, like you can have an ingress for each cluster and route all of the requests that are coming through that ingress to your clusters.
No.
I mean, within the vCluster, each service.
No, say in Kubernetes, my any service name will be service name.namespace.svc.cluster.local.
Yes.
So cluster.local is very specific to my cluster. That I want to replace in my vCluster.
So
with abc.com, in another cluster I want to do xyz.com. It is possible? In Kubernetes, I know it is possible. We can specify some command.
I think then, it should be possible through exposed value with the vCluster Helm charts itself, right? You could specify this. But yes, and within the cluster also, if you want, you wouldn't change anything in your workloads. If a pod wants to communicate with any service within any namespace within the vCluster itself, you could just say the service name dot namespace name dot svc dot cluster dot local, and yeah, the traffic would the DNS would be resolved to that service IP. Yeah.
And can I modify my core DNS that if my service is outside the cluster, how to reach there?
You could again, but yeah, you could.
But I have two virtual cluster on top of my physical cluster. Now, from one service from one cluster, I want to communicate to service in another cluster. Then I have to modify my core DNS server that how to reach outside the cluster.
Yeah, you could like again, all of these core DNS and everything is under your control. You could do that, right? Ideologically, that as a yeah, it should be possible because it's core DNS again, right? You could configure it to like do whatever you want. And it's all under your control. Yeah.
You can also like have egress rules going out of your cluster. So that's, I think, easier to do that.
Good. And sorry, we were just told to wrap up because we are over time, but we'll be around until the end of the talk and after this talk as well. And we encourage you to interact with every speaker that has spoken so far, right? Get your doubts cleared if you had any doubts and everything. And after this, we'll have open for the networking session, and we can definitely talk about these questions, right? So now that brings us to the last very short talk of this, Kubernetes meetup. I think we have an announcement before that, right? Okay, cool. So, yeah.
Thank you, Prakash and Vibhav. That was a great talk. I believe it'll be useful for anybody who's trying to get certified. I guess use the inception version of Kubernetes. Go nuts with it. Let's see where it starts struggling, where time starts really slowing. And yeah, thank you very much for that talk. Now I'll hand it over to Nipendra. I think you already saw what he's going to talk about. You saw the book club. There you go.
Good evening, everyone. My name is Nipendra, and you would have seen me in the community earlier. So how many of you read books on the technical subjects? Couple of folks? Okay, good. So on a similar line, as a CNCF community, we run this virtual Kubernetes book club. So there are two editions we do it in weekly twice. One is on Thursday, which is at 8 p.m., primarily for EMEA folks. And in that particular book sessions, we are currently doing production Kubernetes book. And that is about to end right now, actually, in next 2-3 weeks. But we are going to start another book in a couple of weeks, and we are doing the poll of that in the next session. So it happens on Thursday at 8 p.m. India time. So you can join this book club, and of course, there we kind of dig deep into subjects like in production Kubernetes book that has 16 chapters. We are in 14th right now, and we are doing from last August. So it is not like we are just kind of touching upon very top level. We are going very deep into it. And you can always come and talk about your use case, and we talk about like how you are running in production, what are the issues you have seen, and so on. And so we are seeing participation from India, all the EMEA region there, Singapore, Germany, France, and other places. So you can join that. And then another version of it run at 11:30 p.m. on Friday for the US times. So 11:30 p.m. IST. So there they are starting platform engineering book from, I started yesterday. So you can join those sessions as well. And recordings are also available for all the book club sessions. So you can always go back and join the, look at the recordings there. But this has been a really good, because we can dig deep into topics. There's no time limitation. We can kind of take a topic to other week and so on stuff. And all practitioners are there. So yeah, please join in. Yeah, thank you. No, it's not on the meetup. It is on something called as Bevy. So if you just search for Kubernetes virtual book club, you will get it. That's what I did right now on the thing. I don't have a QR code right now. I'll show you otherwise. But if you just search for Kubernetes virtual book club, that's just sufficient. Yeah, thank you. Yeah, so generally what we do there is we pick up generally books which are available. I mean, sometimes it's free, sometimes you have to buy for it. The way it works is we decide a topic and we have a lead for each chapter. Like this chapter would be led by somebody, right? And that person would be main responsible person for reading the chapter and come and discuss it. But the idea is that everybody go back, read a given chapter, come back and have a discussion. That's how it is. Thank you.
Thank you so much, Nipendra. I encourage each one of you to join the book club. And I've been following the updates from the book club. People talk about how helpful it has been for them, right? So now we have one short talk, a very interesting one that I was looking forward to, right? It's about this project called Zarf, which helps you run your Kubernetes clusters in a air-gapped environment. Air-gapped environment, for those of you who don't know, is an environment where there is no network connectivity to the outside world, right? So yeah, over to you, Vibhav.
Thank you for the introduction. So I don't have any slides or anything for this talk. I started contributing to this project like 3 weeks ago. So it's a very interesting project. So I thought I'd just kind of like go and give a small overview, go over the commands and what it is. So if you have an air-gapped Kubernetes cluster, and if you want to be able to easily move packages from a place where there is internet, and you can like build all of those packages in one place, take it to the air-gapped and deploy it without any internet connection. Zarf helps you with that. The word Zarf actually means like a cup holder when the time there were like cups didn't have holders. So it's like you got your hot tea in this glass and you put it in this like holder and you can like hold it without touching it. So that's the idea, is you can control your Kubernetes environment without actually, like you can control it like remotely from like a jump server or something which has access there. So what I'm going to do right now, I'm just gonna go through like the main Zarf lifecycle. So when you want to deploy a package to Kubernetes, usually you want to like pull all of the images and stuff. So what Zarf does is it ensures that there is a Git server, there's a logging server. Let me actually go to the namespace. Yeah, one sec. So you can see that there is a internal Docker registry running. There are some agent hooks for Zarf itself. There's Loki running, the Loki stack running, and then there is Git, which is the Git server which is running. So this is so that you can just move everything onto Zarf and like run everything from there. The cool thing about this is you can also run GitOps because you have a local Git server that is already running. Some people have ran Argo over here and then triggered like Argo workflows from the GitOps here itself. So Zarf is a pretty powerful tool that way. Now, how do we actually get our apps to the cluster if the cluster is not accessible via the internet? One sec. So yeah. So what Zarf does is, so the most common way we do it these days is Helm charts, right? You just do Helm install and just install it somewhere. What if you can just like now package that Helm chart? So Zarf helps out with that. So we are going to look at like one of the examples of what a Zarf YAML looks like. A very simple one. So this is my favorite one. It's called DOS games. You can run like Duke and like the old games like Mario and stuff on the web, but like in a container. So let's check out the what the configuration looks like. So it's basically like you are just like putting manifest like a normal deployment and service into the cluster. You're creating that. Once it's deployed, it checks, waits for the deployment to come up and checks if it's available. This is the action that runs after the deployment is done. And the reason we have to mention images over here is so that Zarf can pull all of these images, tarball them, and throw it in the package that it creates. So let me actually show you what a Zarf package looks like. So one second. Hello. Yeah. So I think the Zarf UI is actually user interface is actually pretty good. Like it shows you what it's going to do before it's going to do it. It takes you through everything. As you can see, it has pulled all the metadata for the images. It's gotten the image and it's kept the image in this Zarf package DOS games. And this is where the application stays right now. There's the deployment, the images, everything is here. Now, if I don't know if we are kind of starved for time, but I kind of want to just show what's there inside this tarball. So you can see that there are the image blobs. You can see that there's a Zarf YAML and basic, and also the components that you need. The components are each component is an app in Zarf. So in this case, is the DOS game. So now what I'm going to do is I'm going to deploy this to Zarf, to the air gap cluster. So I'm going to do a Zarf package deploy. Okay, so this is the package I want to deploy, the one that I just built. I'm just going to say deploy. Okay, it waits for the replica set to get ready. You can see in the namespaces that DOS games was created like 6 seconds ago. So okay. Do you want to play some games? I think we want to play some games. It's been a long day. So it has this very, very good feature where you can connect to the service that's already running. So first, before we do that, let's go to the namespace and see what's running on the namespace. Yeah, you can see this game pod is running. So what we'll do is we'll actually go ahead and like play some Doom in an air gap cluster and call it a day. Okay. Yeah. Voila. This is running from an air gap cluster proxied through Zarf. And thank you for being here. This was the introduction to Zarf. Are there any questions? Yep.
Hello. What does the SBOM stands for?
Yeah, software bill of materials. It basically it's like a security measure you have to take, which contains like everything that is included in that package. So it's like a security necessity. Yeah. If I wouldn't have remembered that.
So basically, is it that those are getting patched on a regular basis, or what is it?
No, it's for like keeping track of like what's being sent to the cluster. Yeah.
Line item on your bills. Let's say you order 5 So how does the observability work in this scenario? Like you showed a Loki stack running.
Yeah, I haven't gone in depth in observability, but I'm sure that you'll probably be able to only access it from within the cluster. So you'll have to do something like Zarf Connect and like connect.
Can you do port forwarding and stuff if you want to?
Yeah, so that's what Zarf Connect is doing right now. It's port forwarding from that service over here.
Okay, thank you.
Any one example to create this kind of situation where we need to use this tool? For example, I have 3 clusters.
Where you want to play a game on cluster?
No, in general, while working. For example, because ultimately we need access to internet. If you want to upgrade, downgrade, generally we don't downgrade, but at least for a reverse back or take a revert back to the previous version of the application. Okay. Something that normally we do many situations.
Yeah.
But any best example where we definitely need to implement this kind of solution?
So yeah, if you go to the like this is a beginner use case, obviously. This is just to show like how Zarf packages and deploys. But you can go to this Zarf example. you can go to the examples in the Zarf repo, and then there is a Helm chart example, which might be helpful for you. Yeah.
So one more thing, situations where you use air-gapped environments are like government data centers, right? So they have a lot of data centers that they don't want connected to the internet for security purposes, so that like it's very difficult to get through into these data centers. So air-gapped environments for that, there's a gap between the internet and this. They have their network is not connected to the internet, right? So that is the use case where you would use something like Zarf, right? And in air-gapped environments, of course, the challenges are completely different. You would need all your images and everything locally, right? You can't pull anything from the internet or send traffic out to the internet and all of that. So in those use cases, this helps, right? And even like in these data centers, if you as a developer has developed something that they have deployed in it and you're the developer, in case issues arise, you are not someone who actually goes ahead and fixes them. You give them something like a run book where you write down the steps as you perform these should hopefully fix it. And a government employee who has certain amount of privileges to actually do that runs those things and comes back to you with the result. So it's these kind of environments where Zarf helps, right? Can we have more questions towards the end? Right after this also, we'll be around for a bit. You can engage directly with the speakers to understand more about these projects, right? Yeah. So I think yeah. So we have some.
Just give me 1 second. Let me connect the laptop.
Thank you guys for staying for the Zarf till the very end. Thank you so much.
So based on the questions we've received, I'm sure most of you are working on a lot of exciting stuff. We'd appreciate it if you can come be a part of the community and share your knowledge with the rest of us. So that's my colleague and my co-organizers, QR, that's my LinkedIn, and that is the Meetup group. So feel free to connect with us, be a part of the community, and let's talk about what it is that you want to share with the rest of the room.
Thank you so much. And just 5 more minutes and we should be done, right? We usually do this towards the end of every meetup. So this is probably somewhere between 75th to 80th meetup of ours, right? We've been doing this for a very long time. We see a lot of familiar faces who've been with us for a very long time, right? And we are from, so I think most of you RSVP'd from the K8S BLR. We are on Twitter. You can find us on meetup.com as well. You can look us up on Twitter as well. We go by the handle K8S BLR, right? And we do these meetups every month, right? We try and do this meetups every month. So if you're someone, and this is a completely community-driven meetup. So if you're someone who wants to submit a talk at one of our upcoming meetups, you know how to get in touch with us. Our numbers, our handles are everywhere out there, and you can get in touch with us directly as well. If you also, so since it's completely community driven, we would like to thank Cloudera for sponsoring the venue for this meetup. Can we have a round of applause for them, please? And similarly, we try to do this meetup every single time at a different venue so that it's easier for people traveling from different parts of the city, right? So we are always on the lookout for venues, especially new venues. We don't like repeating venues, right? So so that the entire community gets a chance to, be a part of this movement, right? So if you have a venue that you can sponsor us similar to the one here, you can get in touch with us as well on that. And Humble, do you have anything to add? Oh, yes. If you've got any feedback for us, definitely there are things which we believe we can improve with every meetup. If you've got any feedback for us, you can let us know, right? If you have any feedback that you want to give it to us in person, so we'll be around for about 10 minutes after this. Or if you have any feedback and you just want to say it out loud, you can just raise your hand and you can let us know, right? Mike, is there a mic?
I had one question, that is, I'm currently studying in second year of BTech. So I wanted to know how should I start my journey in Kubernetes.
So I think that's where most of us were at some point, right? First of all, a round of applause for, coming from being a student, attending this on a weekend, right? I had a lot of other things to do while I was a student and on a weekend, right? But being involved with the community itself through this meetup, right? I think one place where you'll definitely benefit from this meetup is by networking with people around, right? Talking about, so these meetups are a way for us also to keep updated about what's happening, right? So definitely engage in conversations with different people, and each one can help you in different ways, right? They might be working on certain things, ask open-ended questions on what they're working on and what you can learn from them. I'm sure there's a lot you can learn from people who are over here today, right? So, yeah. So also one more thing that we do, I think we can, you can give the feedback to us directly by talking to us, right? But one thing that we do every meetup is if there are people hiring currently, I'm sure everyone's, companies, some people might be looking for good people to join them, right? Who can be amongst these people, right? If you're hiring in your company or your team, you can come up here, talk for 1 minute about who you are, which company you come from, what positions you're hiring from. And if you're someone who's looking for a job, you can definitely get in touch with them and ask more about that. And yeah, so we'll spend like 2-3 minutes on this. Is anyone hiring? Raise your hand. Yeah, come
on. Prakash, one sec. I'm sorry to interrupt. I'm really sorry to interrupt. But Vibhav wants to leave, and it's a token of thanks. So Vibhav, please. There you go.
How do you work?
And yeah, we'll wrap it up first, please. Sorry to interrupt again. And this is for Prakash. Thank you, Prakash.
Yeah, Mohammed, am I audible? I'm on the Zoom call.
Yes, loud and clear.
This is Vijay Kumar. I work for Cloudera. So someone was talking about if you are hiring, we will get a chance to talk about for a few seconds. I would be really interested in talking about for a few seconds because I have few positions in my team, and I would be really interested in hiring one of the persons, a few of the persons who is here today.
Which company and how can they get in touch with you?
Cloudera.
Cloudera.
Cloudera.com/careers. There you go.
Right.
And Vijay, can you ping us your LinkedIn profile in case people want to hit you directly?
Oh yeah, perfectly fine. I would be pinging out there in this chat. And I manage a platform engineering. Just allow me a few seconds. And platform engineering team here in Bangalore. I have a team of like close to 10 people. And interested in looking out for a person who is good in Python and infra. And the infra, what you already talked about. And these are the two basic things which I'm looking out for. So I'll share my LinkedIn profile here. Please spread this and see if I can get someone on this.
Yeah. Sure. So reach out to us, either of us, and we'll share your profile to Vijay.
Hello. So my name is Amit, and I am working as a DevOps engineer at a startup called OpenInApp. So we are hiring in backend and also in some business domains. So if someone is looking for, starting their career in backend and all, so they can get connect with me and I will refer you.
Awesome. Also, we would like to have a picture with everyone who's here. And if you have any more roles that you're hiring, you can, oh yeah, we have one last we can take. And after that, can we all get a picture, please?
Thing we missed on. There were few who asked questions during the first and second question. We have caps for them. Please come and take it.
So actually, I won't have my company. I'm working at Accenture, and there are openings like for 100 people for React and backend Java Spring Boot. So people working in Java and React can connect with me on LinkedIn and can ping me. So I will refer. My name is Ankit Jain. You can search Ankit Jain Accenture and you will find my name. So
Sorry.
Thank you.
Yep. So that brings us to the end. We really want to thank you for bearing with us for so long. Thank you for coming out on a Saturday afternoon to make this meetup successful. And we hope to see you at our further meetups as well.